Hi everyone! Welcome again to my channel, Math is Fun channel. This channel is an educational channel to help you understand about mathematics. This is also intended to those who are doing the online classes over there. Hi! And also those who are answering their modules. This is very helpful for you to understand your math lessons. And aside from that, this will help you also to really change your perspective that math is not a difficult subject, but it's easy, fun, and interesting. So please do not forget to subscribe my channel and please share this one to your friends out there, especially those who are in need about mathematics, who are in need to know more about mathematics because this video discussion is to help them improve their performance in mathematics. So please share and spread the love, spread the news or the good news about this video discussion. So I guess you're all ready to learn new things about this in this video discussion. So I cannot hold it on. So we will now start rather. So let's have a blast. Okay, our topic for this or in this video discussion will be about solving. Okay, this is just very sorry, so excited. So our topic in this video discussion will be about solving linear inequalities, but particularly we will focus on graphing. Okay, solving and graphing. So our objectives this or in this video discussion are we have to graph intervals on a number line, use the addition property of inequality, use the multiplication property of inequality, solve linear inequalities by using both properties of inequality, and to solve applied problems by using inequalities. Are you now ready? Yes, you are now ready. I can see it on your faces. Unimaginary faces. Okay, so just a recap about solving linear inequalities. We all know that inequalities are algebraic expressions related by the symbols used: less than, greater than, less than or equal to, and greater than or equal to. So we solve an inequality by finding all real number solutions of it, right? So for example, the solution set x such that x less than or equal to 2 includes all real numbers that are less than or equal to 2, not just the integers less than or equal to 2, because 2 is included since because we use the symbol less than or equal to. So 2 and below in that given or in this given inequality. So now our first objective is we are going to graph intervals on a number line. So a good way to show the solution set of an inequality is by graphing. So we graph all the real numbers belonging to set x such that x is less than or equal to 2. By placing a number, by placing a square bracket at 2 on a number line. As you can see the symbol rather, on a number line, and drawing an arrow extending, this arrow extending from the bracket to the left to represent the fact that all numbers less than 2 are also part of the graph. In this given inequality, x is less than or equal to 2. So plot the 2. Since we use less than or equal to, you may use the bracket or the closed ball or circle. So as you wish, you can use bracket or you can use the circular or the closed ball. So it's up to you. And also the arrow is going to the left since it shows that it goes to negative infinity. So from 2 is included to negative infinity. So that's how we do it. So now some text use solid circles, I have said, the closed circle, rather than square brackets to indicate the endpoint is included in a number line graph. So open circles are also used to indicate non-inclusion. Again, as I have said in the previous videos, when we have open circle, that means in graph for intervals, the number is not included, or it shows not included or non-inclusion. So rather than parentheses. So when the endpoint is not included in the graph. So that's how you use the open circle um, or the parentheses as a replacement, or what I mean, as other form of graph in linear inequalities, or inequality rather. Okay, so I guess let's proceed, or we can now proceed to the next. So the set of numbers less than or equal to 2 is an example of an interval on the number line. So to write intervals, we use interval notation. Again, do not forget about the term interval notation. So again, to write intervals, we use what notation? Interval notation. Again, when we try to write intervals to represent the solution set of the linear inequality, then we use interval notation. So for example, the interval of all numbers less than or equal to 2 is written in the form of the symbol on the screen, this one. So it shows uh, the interval of all numbers less than or equal to 2, which is 2 is included, it goes to negative infinity. Of course, you cannot, please take down note, you cannot include the infinity, because the infinity is, it means continuity. So you cannot close it because it goes infinite. So again, you cannot uh, you cannot have brackets, or you cannot have closed ball for infinity, both positive or negative. Why? Because I'll emphasize this one, because you cannot close the infinity. It goes forever in our graph. So I don't like you to forget it, because that is very important concept. Okay, so now let's proceed. Now, the negative infinity symbol, -8, does not indicate a number. That's why you cannot close it, but shows that the interval includes all real numbers less than 2. And another thing that I want you to remember, as on the number line, the square bracket indicates that 2 is part of the solution set. So now, wow, I love the song. I love the backup music, background rather. So please, yeah, please bear with the inconvenience and with the advertisement. So let's proceed. A parenthesis is always used next to the infinity symbol. The set of real numbers is written as this: negative infinity and infinity. As what I have said a while ago, you are not allowed to use the brackets for the infinity and for both positive and negative. Why? Because you cannot close it. The meaning of infinity means continuity. So it is continuous, so you cannot close it. What happened to my voice? You cannot close the infinity because it goes continuity. It shows continuity rather. So it goes forever. So now, write each inequality in interval notation and graph the intervals. So this time we're going to apply about graphing intervals written in interval notation on a number line. So let's have it. Okay, very good. For the first inequality, x is greater than or equal to 3, we can say that 3 goes to the positive infinity. So that is the interval notation, this one. This is an interval notation. Please be guided. So another, what is the graph of it? So of course, you're going to locate 3. So 3 is here. Since 3 is what I mean is, since 3 is included, so we use greater than or equal to, right? So in graph, we can use the brackets. So the bracket shows what? Closed. The 3 is included, and it goes to the right side of the number line. Why? Because it goes to positive infinity. Okay, so that is the symbol and then the graph. Again, this shows the interval notation, and the graph of the given linear inequality x is greater than or equal to 3. What about this one? Oh, this one it sounds challenging. So how will we do this one? Oh, how do you do this? So 2 is less than x and x is less than or equal to 4. So how will you do that one? So what is now your solution? So to solve, of course, 2 is not included and 4 is included. Why? Let's try to observe their inequality symbol. This one means less than. We all know, as I have said, less than or greater than will be using parentheses or open circle. And less than or equal to or greater than or equal to will use the closed circle or the shaded circle, or shall I say the brackets, to show that they are included in part of the solution set. So we have it 2, this one, 2 and 4, where 2 is not included and 4 is included. So how do we do this one? How do you do this? Okay, in graphing. Okay, so as you can see, so this shows a pattern perhaps. So 2 is greater than, since x is greater than or greater than 2, or 2 is less than x, so it goes to the right of the number line. And since x is less than or equal to 4, therefore x goes to the left side of the number line. So they have a common. So this is the solution set of this given compound inequality. Again, since it has three parts, we call it compound inequality. This one is a simple linear inequality. This one is a linear inequality with three parts, or you call it compound inequality. So that's how you do it. I hope you'll be able to follow. So now, objective number 2 is we use the addition property of inequality. So we all know that a linear inequality in one variable can be written in the form of ax plus b less than c, where a, b, and c are real numbers, with a is not equal to 0. And examples of linear inequalities in one variable are x plus 5 less than 2, y minus 3 greater than or equal to 5, 2k plus 5 less than 10 are linear inequalities, as you can see on the screen. And all definitions and rules are also valid for greater than or equal to, and less than or equal to. So consider the inequality to less than 5. If 4 is added to each side, the result will be 2 plus 4 greater than or equal to 5 plus 4. So that gives us 6 is greater than or equal to 9, which gives us a true statement, right? We all know that 6 is greater than or equal to 9. Are you really sure? No, it's not. It must be less than, right? So this one must be, sorry. I just would like to correct this one. Sorry. Oh, we are so far, far away. Okay, this one. Um, So this one, 2 plus 4 and 5 plus 4, 6 is greater than or equal to 9. This gives us false statement, not true, okay? We all know that 6 is less than to 9. So it's false, sorry. Maybe something like problem in the PowerPoint presentation. Okay, now, use the addition property of inequality. Now, subtract 8 from each side. Then that gives us, example, a while ago, we have it 2 and 2 is greater than or equal to 5. So in this example, we can subtract it minus 8 and minus 8. What will happen? This becomes negative 6 and this becomes negative 3. And we all know that negative 6, are you sure negative 6 is greater than or equal to negative 3? Mm-hmm. I don't think so. The result again is a true sentence. These examples suggest that the addition property of inequality, I don't think that it's equal, right? Or what I mean is negative 6 is greater than or equal to negative 3, because negative 3 is greater than or equal to negative 6. I want you to correct this one, okay? So again, another problem in the um, PowerPoint presentation. So for any real number, okay, for a while, for any real number, numbers A, B, and C, the inequalities A less than B and A plus C less than B plus C have exactly the same solutions. So that is the same number may be added to each side of an inequality without changing the solutions. So I hope you can follow. So as with the addition property, as with the addition property, sorry, as the as with the addition property of equality, the same number may be subtracted from each side of an inequality. So I want you to remember that one. So let's have an example. We can appreciate this one if we put this one in an example. So let's have an example. So using the addition property of inequality, solve the inequality, then graph the solution set. So we have the inequality -1 plus 8x less than 7x plus 2. So how do we do this one? Okay. So first, of course, as you can see, we subtracted both sides by -7x. So -7x, we subtract -7x rather to both sides rather of the inequalities. So you have it -1 plus 8x minus 7x less than 7x plus 2 minus 7x. Why is 7x? Because we want to uh, eliminate 7x in the right side of the inequality just to uh, have the like terms, or this one 7x or 8x can be combined through like terms. That's why we subtract both sides by -7x, with -7x rather. So now let's proceed. So we can have it -1 plus x plus 7. As we all know, 8x minus 7x will give us x. And of course, to eliminate -1 to the left side of the inequality, we're going to use the addition property of equality by adding both sides of the linear inequality by 1. So that's why we have it +1 plus 1. I want you to focus on the green mark or color. Okay, so we all know that -1 plus 1 will give us 0. That's why we have x as our left side in our inequality. Then 2 plus 1 is 3. So our answer is x less than 3, or you can write it. This is the solution set. X is less than 3. You can write it in interval notation as this. It goes to -8 and then 3, meaning to say 3 is not included since our symbol for the solution set is x less than 3. So it goes to from 3, where 3 is not included, going to the left side of the number line since it goes to the negative infinity. So I hope you'll be able to remember this one. And also, of course, the next objective that we have for this video discussion is about using the multiplication property of inequality. So let's have a review. The addition property of inequality cannot be used to solve an inequality such as 4x greater than or equal to 28. So this inequality requires the multiplication property of inequality. Very well said. So multiply each side of the inequality 3 less than 7 with a positive number 2. That gives us uh, 2 times 3 is 6 less than, or 2 times 7 is 14. Yes, 6 is less than 14 is a true statement, right? So now multiply by each side of 3 less than 7 by the negative number -5. So we have it -5 times 3, then that gives us, or less than -5 times 7. So we have it -15 is less than -35, which is a false statement, correct? So with that, we can say that to get a true statement, when multiplying each side by -5, we must reverse the direction of the inequality. So you can have it -5 times 3 greater than -5 times 7, then we have it -15 greater than -35. So our statement now is true. Okay, I'm talking about this one. To correct this false statement, we can have, or we can multiply both sides of the inequality by -5. So to make the statement true, this is what I meant in here. Now let's proceed. So in summary, the multiplication property of inequality that I want you to remember has two parts. For any real numbers A, B, and C, with C is not equal to 0, if C is positive, then the negative, then the inequality, sorry, A less than B and AC less than BC, okay, have exactly the same solutions. And another thing also that I want you to remember in here as a summary about multiplication property of inequality, if C is negative, then the inequality is A less than B and AC greater than BC, sorry, have exactly the same solutions. So I want you to remember this. And of course, that is each of an inequality may be multiplied by the same positive number without changing the solutions. So if the multiplier is negative, we must reverse the direction of the inequality symbol. So do not forget that one. And the multiplication property of inequality also permits division of each side of an inequality by the same non-zero number. Haha. Okay, so now let's have an example to apply the steps that we have just discussed about multiplication property of inequality. Solve the inequality, then graph the solution set. So example, we have it there, negative 2r greater than negative 12. Remember about dividing negative or multiplying negative numbers to both sides of the inequality, then the symbol will be reversed. So do not forget that one in my previous video discussions, right? So we have it negative by dividing both sides by negative 2. That gives us, with this answer, okay, r is less than 6. So that gives us, okay, so again, it changes its symbol because we divided both sides of the inequality by negative or by a negative number to make the statement true. That's what I discussed a while ago. So as you can see there, so the interval notation for r is less than 6 is negative negative infinity and 6, where 6 is not included. And as you can see in the graph, plot or locate 6 and then use the parenthesis symbol since it's not included in the solution set. Or you may use the open circle, unshaded circle. So going to the left because again, as I have said, going to the left because the direction is going to the negative infinity. As simple as that. Okay, so that's it. That's how we apply. So next, last, I guess this is the last, solve linear inequalities by using both properties of inequality. So we will use both multiplication and addition property of inequality. So again, to solve linear inequality, use the following steps. First, or step one, we have to simplify each side separately. We can use distributive property to clear the parentheses, and you can also combine like terms on each side as needed only. So step number two is isolate the variable in terms on one side. So use the addition property of inequality to do this one, to get all terms with variables on one side of the inequality and all numbers on the other side. So step number three is isolate the variable. Use the multiplication property of inequality to change the inequality to the form x is less than k or x is greater than k, where k is a number. And of course, do not forget that always remember, reverse the direction of the inequality symbol only when you are multiplying or dividing each side of an inequality by a negative number. So do not forget a one, that is very important. A simple reminder brought to you by Math is Fun channel. Okay, so let's have an example. Solve the inequality, then graph the solution set, given that. So of course, the first step that we're going to do, of course, we use the addition or subtraction property of inequality. So that gives us, of course, 4x plus 2 minus 7x, 7x less than 7x minus 5 minus 7x. So please be guided with this negative 7x that we subtracted to both sides of the inequalities. And next is, of course, we have it, negative 3x. We all know that 4x minus 7x is negative 3x plus 2 minus 2, again, using the subtraction property of inequality rather. less than negative 5 minus 2. Then that gives us negative 3x greater than negative 7. Why did we change the symbol from less than to greater than? Because you divide both sides by a negative numbers. And as I have said, when you divide or multiply both sides of the inequality by a negative number, the symbol will change, okay, or will reverse. So we have it x greater than 7 over 3, or you can have it 7 over 3 going to the positive infinity as reflected on the screen, projected rather on the screen. And it shows that the graph is going to the right side because our solution set is it tells us x is greater than 7 over 3, so it goes to the right side of the inequality, what I mean, of the number line. So let's have another example. So we have it using distributive property. So we distribute 4. So we have it 4 times x, that gives us 4x. 4 times negative 1, negative 4. So negative 3x, this one, negative 2x. Okay, that gives us negative 2x. Negative times positive. Okay, so we have it, okay, negative 1. So negative 1 minus 15, that gives us negative 16. Oh, it's shortcut already, not step by step. So we subtract, we copy negative 3x, then we use the addition property of inequality. So by adding both sides of the inequality by 2x. So this one, we can eliminate this one. So what's next? Let's see what's next. So we have it 3x, why 3x in here? Okay, we all know that 4x minus 3x is 1x plus 2x, we have 3x. So negative 4 minus 4, just copy negative 4, and then we add 4 to both sides of the inequality because we want to eliminate the 4 in here. So we have it negative 16 plus 4. So that gives us, okay, 3x greater than negative 12. And since we're looking for your x or for the solution set, we divide both sides by 3. So our answer now becomes x is greater than negative 4. So as you can see, the inequality symbol did not change because we did not divide both sides of the inequality by a negative number. It's positive. So it can be written in the form of interval notation, negative 4 going to positive infinity. And it's very obvious there on the graph that it shows that negative 4, locate negative 4. Negative 4 is not included because we use greater than. And it goes to the positive, what I mean, the positive side of the number line, which is the right side of the number line. So I hope everybody got it. So that's it. So we will end our discussion in here. Probably we can have the fifth objective next meeting. So that's how you apply the graphing and then the interval notation in solving or presenting the solution set of the linear inequality. So do not forget about that one, okay? So do not forget it. So I'm happy to share my knowledge with you, and I hope everybody got it, that in solving linear inequality, you are not only applying the properties of the inequality, but you are also, you really have to know how to write your solution set in interval notation form and even to graph the linear inequality. That's all for this in this video discussion. Thank you so much for listening. I'm happy to share my knowledge with you, and I hope you are learning so far. If you like my video discussions, please, even if you don't like it, please do not forget to subscribe. And thank you for watching the video until the end of it. So I hope you are learning, and please share this one to your friends out there and even to your classmates. So this is very helpful. Again, always remember before we end our video discussion that math is fun. So thank you and have a good day.